Hello everyone, my name is Rumbizo Carol Sitole and I will be presenting question number 5 on risk theory CBT. So the question says that the number of claims per year follows a binomial distribution with M is equal to 26 and Q is a constant. Claim sizes distributed as in the following table. So we're given this table where Q is the claim size and PX is the probability of this claim size. So S is the aggregate loss random variable subject to a 200 annual aggregate deductible. Probability of aggregate payment more than 800 is 0.0540175. So the question is asking us to compute the value of Q. Okay, I will open the Excel file now. Okay, so as we've seen, the question is asking us to look for Q, and it's a binomial distribution where M is equal to 26. So the given information is that the aggregate payment is, the probability that the aggregate payment is more than 800 is 0.054. So if we were to calculate the probability that our aggregate payment is more than 800 manually, would take forever because it ends at infinity. So it will be easier if we calculate the probability that the aggregate payment is less than 800. Then we subtract the probability that we get from 1, which is the total probability. So one important thing to take note is that aggregate payment is equal to aggregate loss minus aggregate deductible, since we've been told that there's a deductible of 200. So if we want our aggregate payment to be 800, it means that our aggregate loss has to be 1,000, so that we get 1,000 minus 200, which is 800. So if we want the probability that the aggregate payment is more than 800, it means that we'll be calculating that the aggregate loss is more than 1,000. So if we are to come here on our tables, this is why you will find that our probability here, or our N or S, which represents the probability of our aggregate loss, will be up to 1,000, and our aggregate payment will be up to 800, which is the probability that we're going to get. So we are kind of going to work backwards for us to get our Q using the information that we're given. So in calculating our probability, we are going to use the recursive formula, which is 1 over 1 plus A, probability of X is equal to 0, summation from J is equal to 1 to K, with A plus B over K, probability of N minus 1, which is the previous probability. So as we can see, we need to use A and B. So this is why here on this table, the small table, we'll have our M and our Q. I will delete this so that we see how we get this figure. So we get Q using a special function on Excel called solver. So we will see how we get this value. I've just removed our Q. So A is a negative Q over 1 minus Q, and B is M plus 1 multiplied by Q over 1 minus Q. So here, this is the formula of the recursive formula. I kind of split it so as to reduce the cell references, or so that it doesn't become complicated. So I did the first one here, and then we have our N or our S, then the probability of S. So this is where we'll be using the recursive formula. But with the first one, we just use 1 plus Q multiplied by probability of 0 minus 1 to the power G11, which is our M. And also we can see from the recursive formula that it starts from J is equal to 1 to K. So this is what explains why our probability of when N is equal to 0 or S is equal to 0 will have a slightly different formula. So from 1 or when N is equal to 50 right up to 1000, we use the recursive formula respectively, referring to this cell and also A plus B and probability of N minus 1, which will be the previous cell, as we can see here. And then also as indicated, our Y is aggregate payment, our S is aggregate loss. So Y, if we're looking for Y is equal to 800, it means our S has to be up to 1000. So our Y will be up to 800. And also another special thing here is that because we have a deductible of 200, so it means that if our aggregate loss is anything less than 200, our aggregate payment will be 0. So we use the if condition here. So if our N or our S is less than 200, we get 0. If it's more than 200, we get J5 minus 200, which will be our N or S minus 200. So this is why for 50, 100, 150, 200, we are getting 0. And we start getting figures from 250, because this is where we get figures which are above 200. So to use the solver here, I'm going to click here. Since we said we're going to calculate the probability of the aggregate payment is less than 800, then we subtract it from 1. This is what I indicated here, 1 minus the summation of K5 to K25. So I'm going to click here, and then you come here where it's written data, and then on your far right, you look for solver. You click solver, so it's going to pop up a window. So on the window here, you can set up your objective. So the objective that I set is the probability that our aggregate payment is more than 800, which is 0.08540,175 as the question gave us. And then by changing variable cells, the cell that we're changing is G12, which is the Q that we're looking for. So the variable cell is the cell that you're looking for. So you can set up constraints if you want, like for example, you can say Q is greater than 0, because we know Q is probability of success. So it can only be between 0 and 1. But here I didn't. So you can set up here, you select the solving method. This is a nonlinear equation, so this is why I used nonlinear. If it's linear, you can use linear, and we have other options here. Then you click solve. So it will pop up that a solution was found as all the conditions were satisfied. So you click OK, and then it sets up your Q value. So as we can see, our Q is between 0 and 1, and our A is negative, as we know for a binomial distribution, and our B is positive. So this is how we get our Q value.